Certain types of word problems, for example, some geometry applications, lead to quadratic equations. So we're going to show you how to use quadratic equations with those kinds of word problems in this unit video. It's particularly important to check the solutions we get for these quadratic equations because sometimes the stipulations of the problems will leave us having to get rid of one of those solutions. Okay, so let's look at our first problem here. It says the top of a local cable television tower has several small triangular reflectors. The area of each triangle is 49 square centimeters, and the altitude of each triangle is 7 centimeters longer than the base. Now they want us to find the altitude and the base of one of those triangles. So the first thing I'm going to do is draw myself a picture of one of these real little reflectors. And I know it's a triangle, I don't know what kind, so I'll just draw a generic triangle. And I do know some information about this triangle. I know that the area of this triangle is equal to 49 square centimeters. Now, I probably shouldn't call the altitude A right here, since I'm using A for area. Alright, I also know that the altitude of each triangle is 7 centimeters longer than the base. So if I let the base be B, I know that the altitude or height of this triangle is equal to B plus 7. Now I should also know that the area of a triangle is equal to 1/2 times the base times the height. You might also see this formula written as base times height over 2, and I tend to like that one more than I do the other. Alright, so using the information I've been given, the 49, the base, and the altitude, I'm going to plug those things into my formula for B, H, and A. So in for my area, I'm going to put 49, because my area is represented by that. My base is still B. My height is B plus 7 for the altitude. So times B plus 7, all divided by 2. Now all that's left for me to do is to solve this equation. So to get rid of the 2, I'm going to multiply each side by 2. And that gives me 98 equals B times B plus 7. Distribute the B and I get 98 equals B squared plus 7b. And now we have a quadratic equation because we have a squared term, and that's the highest exponent. So my next step in solving something like this is to move the 98 over with the other things. So I do that, and I get, come over here, b squared plus 7b minus 98 equals 0. Now at this point it's up to you how you would like to solve it. If you'd like to factor, go ahead and factor. If you would like to use the quadratic formula, that is perfectly fine too. I will tell you that this one is easy to factor. I know that to get a negative 98 when multiplying, I need negative 7 times 14, and those added together give me 7. So b plus 14 and b minus 7 equals 0. Breaking those into the two equations, I would get b is equal to negative 14. And b is equal to 7. And now thinking about the context of our problem, I know that I can't have a negative measurement. So the only choice for my base would be a base of 7, and we're measuring it in centimeters. So I need to make sure that I put 7 centimeters. Now our question also asks us to find the altitude. Well, if I know the altitude is the base plus 7, I know that the altitude is 7 plus 7, so that would give us an altitude of 14 centimeters. Okay, let's take a look at another example that's really a geometry application. It says Carlos lives in New Mexico City. He has a rectangular brick walkway in front of his house. So I know we're going to be dealing with a rectangle. The length of the walkway, so let me go ahead and draw a rectangle while we're reading here. The length of the walkway is 3 meters longer than twice the width. So I know both of these are that. And I don't know the width. The area of the walkway is 44 square meters. Find the length and the width of the rectangular walkway. Okay, so the area is 44 square meters. Okay, now I know to find the area of a rectangle, I have to do length times width. And so I'm going to plug in the stuff that I've labeled on my picture for my length and my width. So I'm going to do 2w plus 3 times w. And now all I have to do is solve for w. So I'm going to distribute here. It gives me a equals, whoops, I guess I could substitute for my a, couldn't I? Let me erase that. Alright, now after I've substituted the 44 in for a because I knew that it was an area of 44, and I've distributed my w here, I can go ahead and move the 44 to the other side and solve the quadratic equation. Now again, at this point, it's up to you whether you would like to solve it by factoring if possible, or with the quadratic formula. The quadratic formula will always work if you can't come up with the factors you need. And if there are no factors that make it work, then you have to use the quadratic formula. So I'm actually going to factor this with my little factor x. Alright, so using my factor x over here to the right, this will give us some review time for factoring. I know that negative 8 times 11 gives me negative 88, but when added gives me positive 3. So now I'm going to use these two terms to split the middle. Okay, so after splitting the middle here, and then factoring out the common factor out of these two terms and these two terms, I get this factored form of the quadratic is w minus 4 and 2w plus 1. So now I take each of those to solve. I'm going to do it over here to the right. W minus 4, that means w can equal 4, or w can equal negative 11 over 2. Well, I know again, since we're working with length, I have to go with the w equals 4, and that 4 is in meters. Now, since the question asked for length and width, I go and take that w, substitute in here for my length. So 2 times 4 is 8, plus 3 makes 11 for my length. So here you have the two answers that we need, the length and the width by the stars. Alright, this last example deals with some things you may come across in a physics course or even a calculus course in college, which some of you will have to take as part of your major. And when an object is thrown upward, its height in meters is given approximately by this quadratic equation. H represents how high it was initially at the beginning. V represents how fast it was moving. And T represents the time in seconds starting from the time the object is thrown. So we're going to use that information to answer the example that follows. It says the tennis ball is thrown upward with an initial velocity, we're going to need that, of 8 meters per second. Suppose the initial height above the ground is 4 meters. At what time, t, will the ball hit the ground? So we're looking for t in this instance. Alright, so first I'm just going to write the equation that we were given at the top. Try to, that's a 5. I'll make that more cursive. There we go. Alright, now in this case, our s is going to be 0 since the ball will hit the ground eventually. So I'm going to plug a 0 in for s, and then I'm going to plug in an 8 for my velocity and a 4 for the initial height. Alright, so there is all my information plugged in, and now this equation is all set up either to factor or to do the quadratic formula. Now this one is factorable, but I'm going to go ahead and use the quadratic formula in this case just to give us another look at that from what we learned the last couple of days. Alright, so I've written out the quadratic formula, and remember it's easier to do the discriminant first because it makes it not as messy when we're writing it out in the quadratic formula. So keep in mind that this is my A, my B, and my C. And so the discriminant is b squared minus 4 times A times C. And if I work that out, I get 64 plus 80, which gives me a value of 144. And so my discriminant being bigger than 0, I know I'm going to come up with two real solutions, but because this is a word problem, I may not be able to use both of those solutions. So now, going back to my quadratic formula, I've got x equals the opposite of b. So since b is a positive 8, I'm going to use negative 8. Plus or minus my discriminant, which I found to be 144, the square root of that, all over 2 times a, and since a is negative 5, that will be negative 10. Now I know that the square root of 144 is 12, so this is going to be x equals negative 8 plus or minus 12 divided by negative 10. And now I'm going to go to the next slide in order to finish working this out to give myself some more room. Okay, so here's where I left off on. We've got negative 8 plus or minus 12 divided by negative 10. So that gives me negative 8 plus 12 divided by negative 10. Or x could be, and really we're solving for t. I should have used t instead of x. Negative 8 minus 12 divided by negative 10. Alright, so that gives me 4 over negative 10 for this one, which reduces to negative 2/5. So my x, or t really, we should say, can be that, or it can be negative 8 minus 12, that would be negative 20, divided by negative 10 would be positive 2. Now, much like in the case of the rectangle and the triangle problems, I can't measure time negatively. So my answer in this case would be this one, because it is the positive answer. So what it means in the context of our situation is that the ball will strike the ground 2 seconds after it is thrown. So let me make sure I put 2 seconds right here. And that's our video for tonight.